Additional Maths, Algebra 9. Simultaneous equations solved by elimination. Simultaneous equations. If an equation involves two variables or letters, there'll be a range of pairs of values that satisfy the equation. For example, if we take the equation x plus y equals 6, this has many possible solutions. For example, x could equal 0, y equals 6. If x equals 1, then y equals 5. If x equals 2, then y equals 4, and so on. If x equals 3, y equals 3. And so there are an indefinite number of possible solutions. If each of these pairs are plotted on a graph, they form a straight line. If we draw the graph of another equation, say y equals 2x, this has the values: if x equals 0, y equals 0. If x equals 1, y equals 2. If x equals 2, y equals 4. If x equals 3, y equals 6, and so on. And if we plot these points, we get another straight line. Now there's only one point, the point 2, 4, which lies on both lines. So x equals 2 and y equals 4 is the only solution that makes both these equations true together. We say the pair of simultaneous equations, x plus y equals 6 and y equals 2x, has solution x equals 2 and y equals 4. Now, solving pairs of simultaneous equations can be done by drawing a graph. But there are other methods. One of these is elimination. Suppose we have the following two equations: x plus y equals 17 and x minus y equals 9. If we add them together, we get x plus x is 2x, y plus minus y is nothing, and 17 plus 9 is equal to 26. So 2x equals 26. And if we divide by 2, that gives us x equals 13. Now we can substitute x is 13 into one of the equations. X plus y equals 17. So substituting x, 13 plus y equals 17. Subtracting 13, y equals 4. So the pair of simultaneous equations has the solution x equals 13 and y equals 4. Let's look at another example. Solve the pair of equations 3x plus y equals 27 and x plus y equals 11. Now if we write them down one underneath the other and then subtract them, we have 2x equals 16. So dividing by 2, x equals 8. Now if we substitute x is equal to 8 in the equation x plus y equals 11, we have 8 plus y equals 11, and so y equals 3. This gives us the solution x equals 8 and y equals 3. Now let's have a look at a slightly harder example. Suppose we want to solve the simultaneous equations 5x plus 2y equals 38 and 2x plus y equals 16. If we add them together, we get 7x plus 3y equals 54. If we subtract them, we get 3x plus y equals 22. Now in neither of those cases does it help us find the value of x or find the value of y. However, what we can do is double each term in the second equation. Starting with 2x plus y equals 16 and multiplying by 2, we get 4x plus 2y equals 32. And if we subtract this from the first equation, this gives us 5x plus 2y equals 38 minus 4x plus 2y equals 32, which gives us x equals 6. Now we can substitute that into one of the equations, say 2x plus y equals 16, and that gives us 2 times 6 plus y is 16, 12 plus y equals 16, and so y equals 4. So we have as a solution x equals 6 and y equals 4. Now we can check this. If we looked at the left-hand side of the first equation, that gives us 5x plus 2y, which is equal to 5 times 6 plus 2 times 4, which works out to be 38, which is the right-hand side. If we look at the second equation, the left-hand side is 2x plus y. That's 2 times 6 plus 4, which is equal to 16, which is the right-hand side of that equation. So we have the correct solution. So, when we have a pair of simultaneous equations, it's possible to eliminate one of the letters by adding or subtracting the equations. However, it is often necessary to multiply one or both of them by a suitable number or numbers. For example, let's solve 2x plus 3y equals 11 and 5x plus 2y equals 33. Now what we'll have to do is multiply the second equation by 3 and the first equation by 2. So multiplying the second equation by 3 gives us 15x plus 6y equals 99. And multiplying the first equation by 2 gives us 4x plus 6y equals 22. If we subtract, that tells us 11x equals 77. The y terms disappear. And so dividing by 11, x equals 7. Now if we substitute x equals 7 in one of the equations, say 2x plus 3y equals 11, then we have 14 plus 3y equals 11. So if we subtract 14 from both sides, that gives us 3y equals minus 3. And if we divide by 3, y is equal to minus 1. So we end up with x equals 7 and y equals minus 1. Now it's worth checking. For the first equation we have 2x plus y. That's 2 times 7 plus 3 times minus 1, which is 14 minus 3, which is equal to 11 as required. And for the second equation we start with 5x plus 2y. So that's 5 times 7 plus 2 times minus 1, which is 35 minus 2, which is 33, which is what we wanted. So x is 7 and y equals minus 1 is the correct answer, and we've checked it. Let's have a look at another example. Solve the pair of simultaneous equations 8x plus 5y equals 113 and 4x minus 3y equals 29. Well, to solve this, we're going to have to multiply the first equation by 3 and the second equation by 5. If we do that, the coefficient of y will be the same in each equation. Let's see. We start with 8x plus 5y equals 113 and 4x minus 3y equals 29. If we multiply the first one by 3, that gives us 24x plus 15y equals 339. If we multiply the second one by 5, that gives us 20x minus 15y equals 145. So we have plus 15y and minus 15y, and if we add those together, that'll give us nothing. So adding the two equations gives us 44x equals 484. Now if we divide by 44, that gives us x equals 11. Now if we substitute x is 11 in 8x plus 5y equals 113, we have 88 plus 5y equals 113. Subtracting 88 from both sides gives us 5y equals 25, and so y equals 5. So our final solution is x equals 11 and y equals 5. Now there follows an exercise. It's worth pausing the video at this point and having a go at these yourself. When you restart the video, I'll go through the solutions. Okay, here are the solutions. In question A, we have 4x plus y equals 22 and x plus y equals 7. If we write those down as a sum and then subtract, we'll have 4x take away x, which is 3x. The y take away y disappears, and 22 take away 7 is 15. So 3x is 15, and if we divide by 3, x equals 5. If we substitute x is 5 in the equation x plus y equals 7, we have 5 plus y equals 7. In other words, subtracting 5, y equals 2. So the solution is x equals 5, y equals 2. Now we can check this. In the first equation we have 4x plus y. That's 4 times 5 plus 2, which is 20 plus 2 or 22 as required. And the second equation, x plus y, is 5 plus 2, which is 7 as required. In question B, we have 5x plus 2y equals 37, and x minus 2y equals 5. If we write them one underneath each other and then add them, 5x plus x is 6x, plus 2y and minus 2y disappear, and 37 plus 5 is 42. So 6x equals 42. If we divide by 6, x equals 7. Now, if we substitute x is 7 into the equation 5x plus 2y equals 37, then 35 plus 2y equals 37. Subtract 35 from each side, and we have 2y equals 2. Divide by 2, so y equals 1. And our solution is x equals 7, y equals 1. We can check that 5x plus 2y is 5 times 7 plus 2 times 1, which is 35 plus 2, which is 37, which is correct for the first equation. And x minus 2y is 7 minus 2 times 1, which is 7 minus 2, or 5, which is correct for the second equation. In question C, we have 5x minus 3y equals 21, and x plus y is equal to 1. In this case, we're going to have to multiply, because the numbers in front of x and the numbers in front of y in either equation are not the same. Now, let's multiply the second equation by 3. This gives us the two equations, 5x minus 3y equals 21, and 3x plus 3y equals 3. Now if we add them together, 5x plus 3x is 8x, minus 3y plus 3y disappears, and 21 plus 3 is 24. So that gives us 8x equals 24. If we divide by 8, that gives us x equals 3. Now we know x plus y equals 1, so if we substitute x, we have 3 plus y equals 1. If we subtract 3, we get y equals minus 2. So the solution is x equals 3 and y equals minus 2. Now we can check by substituting those in the original equations. 5x minus 3y is 5 times 3, take away 3 times minus 2, which is 15 plus 6, which is 21, which is correct for the first equation. And x plus y is equal to 3 plus minus 2, which equals 1, so that's correct for the second equation. So x equals 3 and y equals minus 2. In question D, we start with 3x minus 2y equals 18, and 2x plus 3y equals minus 1. Now, to get the numbers the same for one of the letters, we could multiply the first equation by 3 and the second equation by 2. This gives us 9x minus 6y equals 54, and multiplying the second equation, 4x plus 6y equals minus 2. Now if we add them, 9x plus 4x is 13x, minus 6y plus 6y disappear, and 54 plus minus 2 is 52. So we have 13x equals 52, and if we divide by 13, we have x equals 4. Now if we substitute that in one of the equations, say 2x plus 3y equals minus 1, we have 2 times 4, which is 8, plus 3y equals minus 1. If we subtract the 8, we have 3y equals minus 9, and if we divide by 3, y equals minus 3. So our solution is x equals 4, y equals minus 3. We can substitute those in the original equation and check that they are the right answers. In question E, we have 2x plus 7y equals 2 and 2x plus y equals minus 10. Now in this case we've got 2x in both equations. So if we write them down and subtract, we'll have 2x plus 7y equals 2 and 2x plus y equals minus 10. So subtracting, 6y equals 12. 2 take away minus 10 is 2 plus 10, which is 12. So 6y equals 12, which means if we divide by 6, y equals 2. Now if we substitute that in one of the equations, say 2x plus y equals minus 10, we'll have 2x plus 2 equals minus 10. Subtracting 2 gives us 2x equals minus 12. And if we divide by 2, x equals minus 6. So x is equal to minus 6 and y is equal to 2, and we can check that that is the correct solution. Finally, for question F, we have 5x minus 4y equals 28 and 2x minus 3y equals 7. Now, we want to get the numbers in front of one of the letters the same. So if we multiply the first equation by 3 and the second equation by 4, that will make the numbers in front of y the same. So if we multiply the first equation by 3, this gives us 15x minus 12y equals 84, and the second equation multiplied by 4 gives us 8x minus 12y equals 28. Subtracting, 15x minus 8x gives us 7x, minus 12y take away minus 12y is minus 12y plus 12y, which is nothing, and that's equal to 84 take away 28, which is 56. So 7x equals 56, and if we divide by 7, x equals 8. Now, if we substitute that in one of the equations, say 2x minus 3y equals 7, we'll have 16 minus 3y equals 7. If we subtract 16, that gives us minus 3y equals minus 9. And if we divide by minus 3, that gives us y equals 3. So x equals 8 and y equals 3. And we can check to see that this is the correct solution.